Okay, hello. So this is video 2, section 14.1, and I want to talk about more examples. I want to start with example 5 from the PowerPoint, which is attached on Canvas for you. Example 5. Factor out GCF. In example A, we have 4x minus 20. So how are we going to do it? GCF between 4 and 20, it's going to be 4. And the expression 4x has x, 20 does not have x. So technically the GCF of 4x and negative 20 is 4. So what you're going to do next, you're going to rewrite the original expression 4x minus 20, and you're going to put that GCF, which is 4, in front of the parenthesis. Okay, so we factor GCF, which is 4. Next, what we're going to do, in the parentheses, of course, you're going to have a minus because your expression has a minus, but what goes inside of the parenthesis? You take your original first expression, which is 4x, and you divide that by your GCF, which is 4. That will give you x. So this x goes inside of the parenthesis. Okay. Next, what you're going to do, you're going to take the second expression, which is negative 20, and you're going to divide by GCF, which is 4. That will give you negative 5, and that negative 5 goes inside of the parenthesis. So 4x minus 20, when you factor your GCF, which was 4, is the same as 4 times x minus 5, and you always can check work. You can do the distribution. It's definitely correct. 4 times x is definitely 4x, and 4 times negative 5, it's definitely negative 20, which is our original example. So that was A. We're going to do B. Okay, let's do B. What I want you to factor, you have 6w squared plus 3w. So to factor this expression, first find GCF, because you're going to factor GCF. So GCF between 6 and 3, it's going to be 3. Okay, you have 6 and 3. GCF of 6 and 3 is 3. Then you have w squared and w. So GCF of w squared and w, it's always the expression to the lowest exponent, which is w. So the final GCF of 6w squared plus 3w is just 3w. And now you need to put the expression in the parenthesis. So what you're going to do, you're going to take your original expression, you're going to take that 6w squared and divide by GCF, which we find, which is 3w. That will give you 6 divided by 3, which is 2. W squared divided by w will give you w. So 2w will go inside of the parenthesis. Then you take 3w, divide by GCF, which is 3w. That will cancel completely, which means you're getting 1, and 1 goes inside of the parenthesis. Since it's positive, you're going to put plus 1. So we factor 6w squared plus 3w, it's the same as 3w times 2w plus 1. You can always check work. Check your work, especially at the beginning, and see if 3w times 2w plus 1 will give you your original expression. So you're just going to do distribute, which is 6w squared plus 3w. So we correct. We are good here. Next, I'm checking the examples, factoring the GCF. I will just do one extra example with factoring the GCF. So this is example 10 from PowerPoint. We have to factor out GCF, the same thing. Let's just do one extra. So we have 50s to the third power t minus 40 st squared plus 10 st. Okay, so first find GCF before you factor. So I'm going to organize them. First, I'm going to find the GCF of integers. 50, you have 40, again, you can ignore the sign at this moment, and 10, the GCF of those three numbers is 10. Okay? Okay, now I'm going to talk about the variable s. GCF of s to the third power s, and the third expression also has s, is s. You pick the variable to the lowest exponent. And GCF of t, because that's what I have in the first expression, t squared, t is t. You pick the variable to the lowest exponent, the variable which repeats. So GCF of 50s to the third power t minus 40 st squared plus 10 st is, and you're putting all of them together, 10 st. That's your GCF. So we need to factor 10 st from that original expression. So factor out 10 st from original expression. We have 50 s to the third power t minus 40 s t squared plus 10 st, and I'm factoring GCF, which is 10 st. Don't forget it's a product, it's a multiplication between each of them. So we're factoring. Okay, so what's going to happen? You take your original, so here I'm showing work. Okay, so I'm taking original 50s to the third power t, and I divide that by GCF, which is 10 st, and that will give me 50 divided by 10, you're having 5. S to the third divided by s will give you s to a second power, and t will cancel. So we're getting 5s squared. Then I'm taking original, which is negative 40 s t squared. Take your original expression with the operation which is in front of it. So hopefully you guys can see it, that we have three expressions here. 1, 2, and 3 right here. Okay, so you're taking that negative 40 s t squared, you're going to divide that by GCF, which is 10ST. And in blue, what we're getting from that division, that's what goes inside of the parenthesis. So you're getting negative 4, S cancel, T squared and T cancel, so we end up with negative 4T. Okay? And that goes inside of the parenthesis. And take the last expression, which is 10ST, divide by GCF, which is also 10ST. Everything cancel completely, so don't forget that everything cancel completely, you end up with 1. Okay, you had 3 expressions, that means you have to have 3 expressions in the parenthesis. And that 1, it's positive, so plus 1. Okay, so we factor the original expression. Again, you can do the work and you can do the simplify the right side, distribute, and you will end up with original expression. Next, what I want to talk about it is factoring out negative factor. So let's just do one example. Factoring out a negative factor. It's the same type of work. You just have to factor negative number, and usually you're doing that when you have mix of positive and negative. So let's do one example. This is example 8 from PowerPoint. Factor out negative 4PQ. Okay, and your original expression is negative 12 P to the 3rd power Q minus 8 P squared Q squared plus 4 PQ to the 3rd power. Okay, so what they want you to do, they want you to factor, and they're telling you what is your GCF, negative 4PQ. So negative 4PQ goes inside of the parenthesis. Let's just move that. That will give us negative 4PQ. Okay, that will go inside of the parenthesis, and we'll have to fill up the parenthesis. So let's show work for that. The same scenario, you take your original expression, the first original expression, which is negative 12P to the 3rd power Q, and divide that by GCF, which is negative 4PQ. Continue with the division. 12 divided by negative 4 will give you negative 3. P to the 3rd power divided by P will give you P squared, and Q will cancel. So we end up with, from that division, with negative 3P squared. That's what goes inside the parenthesis. And you can always check when you multiply GCF by negative 3P squared, you end up with that negative 12P to the 3rd power Q. Next, take the second expression, which is negative 8P squared Q squared, and divide that by GCF, which is negative 4PQ. Continue with the division. Okay, negative 8 divided by negative 4, that will give us 2. P squared divided by P will give you P. Q squared divided by Q will give you Q. And what we end up with goes inside the parentheses, since this is positive, so we're putting plus 2PQ. Okay, and one more. The third expression is positive 4PQ to the 3rd power divided by GCF, which is negative 4PQ. To the division, so 4 divided by negative 4, it's negative 1. P divided by P, it's 1. Q to the 3rd power divided by Q will give you Q squared. and that goes inside of the parenthesis, minus 1 q squared. Okay, so the final answer, let's just rewrite it, everything nicely. So our solution, again, is the GCF, which is negative 4pq times negative 3p squared plus 2p q minus, again, 1 times q squared is just q squared, so we can skip that one. So that's the answer. Okay, and last example, I want to talk about factoring out binomial. Technically, what you're going to do, you're going to factor the parenthesis which repeats. So let's do one example. With factoring out binomial. You're going to see that technically what you're doing, you're factoring the same expression, the same parenthesis which repeats twice. So let's just do one example only. I don't think we need more of that. 8y times 8 plus b plus 9a plus b. Okay, when you're factoring, just remember, note, don't distribute, okay? Don't distribute. Factoring is the opposite of distribution. This expression, it's good the way it is. Okay, so what is your GCF? Your GCF, it's actually the expression which repeats. So the GCF doesn't have to be just integer or mix of variables. It also can be the expression which repeats. So how are we going to factor this? Parenthesis a plus b repeats. So this is the greatest common factor. Okay, so to factor this, 8y parenthesis a plus b plus 9a plus b. We're going to factor the parenthesis which repeats, which is a plus b. Okay, times, open the new parenthesis, and we're going to do exactly the same work. So your first expression here is 8y times a plus b since we factored the GCF, which is a plus b. When you're doing the division, parentheses cancel and you end up with 8y. So 8y goes inside of the parenthesis. And you're going to do exactly the same work. Take the second expression, which is 9 times a plus b, divide by GCF, which is a plus b. Like you see, the parentheses cancel, you end up only with 9. That 9 goes inside of the parentheses. It's positive, so you're putting plus 9. Okay, so final answer. So the final solution, 8y times a plus b plus 9a plus b is the same as a plus b times 8y plus 9. Of course, for homework or test, you don't need to show all that work, okay? Okay, let's do one more example like this. And we will be done. Okay, so b, factor 2w, parenthesis x plus 3, minus 5, parenthesis x plus 3. So your GCF, greatest common factor, is the parenthesis which repeats, which is x plus 3. So what we're going to do, we're going to factor out GCF. So 2w x plus 3 minus 5 x plus 3 equal x plus 3 parenthesis which repeats times, and that should be quick right now. So technically, look what happened. X plus 3 repeats. We already have that in front of the parentheses, so inside you just put 2w. X plus 3 I already factor, so what is the left? Negative 5. That goes inside the parenthesis. So this is the solution. Okay, thank you for watching. I'm going to pause this video right now for you on Canvas.